Thanks and kudos to Mike Pensinger for donating the linear rail and the slide bearing. Thanks. Hey, just going to jump in here and say, do not over tighten any of these screws. This piece doesn't really need to be tight at all. It's just kind of a guard. And even the motor mounts don't need to be super tight. Some LowRider makers have cracked their core by tightening down too hard on the motor mount screws. And of course, as you see me showing here, there's a little cutout in the back of the motor mount that's made to accommodate the wires. There's also a little slot, kind of a little groove in the core itself. Make sure your wires are in that free space between that notch and that groove. If you pinch your wires, you could be in for trouble later on down the road. I made the mistake of reusing the existing screw, which has a tall, boxy head, instead of using the low-profile M5 by 30 millimeter screws that I showed a moment ago. And because that head was standing proud on the lower of those two left mounting screws, that came back to bite me with a collision with the slider. Here you see me installing the mount, the base, for the kinematic accessory holder, the tool mount. As you can see, it shares one of the screws that would normally mount a dust shoe, which in this case mounts the guard, and it shares another screw with the lower motor mount. In both cases, those would have been 30 millimeter M5 screws that have been replaced by 45 millimeter M5 screws. And it looks like it's time to finally get started on mounting the upper motor mount, which is also now a mount for the upper launching point of the floating Z action. And there is a red plastic ring here that the flex hose attaches to, and I did not glue mine in so that I could get it back out to be able to have access to the getting a tool in through the access hole to get through to the screw. And if you have difficulty with that ring getting pulled out, then you could always glue it in at the last step, but you want to go ahead and kind of get things put together. But if you've got a nice friction fit like I do, then you will hopefully be able to get by without gluing it in, so that if you ever needed to remove it to get access again, you'd be able to. And of course, other options include drilling it out if you've glued it in and need to get through, or even just melting a little gap in it with a soldering iron. I'm leaning back to check the height of the collet nut at the bottom of the router to make sure that it's just above the edge of the bottom of the core. My thinking is that if it bottoms out unintentionally, you want the core to hit just before the collet nut so you don't have the collet nut creating added friction for risk of fire. I think that's maybe Ryan's thinking. But my thought process is to have that collet nut just barely above the bottom edge of the core. And once again, I'm just barely snugging up these motor mounts enough to keep that router secure. There's no need to crank on these, and I mentioned before, if you over tighten, you can actually crack the core. And there's not that much force pushing up on this router, requiring it to be enormously tight. My current design has a countersunk area that is a little bit too deep, and so I had to add a couple of washers to each of these M3 screws in order to get things to actually tighten up. If I change the design so that that countersunk area is not so deep, then you would not need to add M3 washers. Here, as I start to check the up and down range of motion, I'm not yet noticing that it's not making it to the bottom. It's bottoming out too early. I'll later notice that it's doing that and find that it's hitting a proud screw head that's sticking out on the bottom screw on the left side. I eventually took that screw and just ground off the head because I couldn't remember at the time if that was indeed a 30 millimeter screw or something else. And if I had remembered that it was just a 30 millimeter screw, I could have simply replaced it. But I must have been a little drowsy or something. Anyway, I ground the head off of it and got it where it wasn't proud anymore. And so then that took care of that. In anticipation of testing 3 different slip-on shoes, quarter open, half open, and full open, I went ahead and cut 2 more sets of foam bristles. These are bristles cut out of EVA foam as shown in an earlier video. And this time, in order to prevent smoky discoloration on the bottom side of the bristle sets, I laid a sheet of paper down first on the honeycomb bed of the CO2 laser to kind of absorb any smokiness and to protect the foam, and it did a good job. They came out without very much discoloration at all. And so here I am cutting them out, and then later I'll go ahead and insert them into the printed parts. I should also mention regarding those shoes, I later found that the iteration that was current at the time was a little bit too wide near the section that goes in up against the core, and I actually had to redesign the shoes and reprint them. So the ones you see here are not the ones that finally made the cut, so to speak. No pun intended. Somewhere along in here, I finally realized that I wasn't getting full range of motion, found the collision with that screw head, and got that taken care of. Okay, so the reason why I'm not getting full range of motion is that there is a screw right there that is not, it's standing proud. Its head is too big and this process is hitting it. Okay, so I just ground down the top of that screw because I wasn't really sure that I had one that was the right length, that had a shallower head. Now I have full range of motion. Okay, there's not enough clearance on this top plate around the collet, and there's not enough clearance between the backside edge of this and the inside lip of the core. So I'm going to need to do something about that, because as this is pushing up, it's making contact against the backside of the core. Okay, I sanded this down a little bit, and I don't know if it was enough to help, but I'm just going to try it out and see. Basically, this thing has a temptation to sit crooked just a little bit, and when it does, it hits the far side over there. When it's kept straight, it still hits it even a little, and if it's crooked, it really hits it. Basically, to have moving parts where we didn't used to have moving parts, we need more clearance. So I've got to remix this part. Okay, so I sanded even more off of these prototype parts. A little bit of a rough job there. You can see this side is unsanded and this side is sanded. And hopefully you can tell, took quite a bit off. And that seems to help it be able to have full range of motion without hitting. So I can remix this part to give more clearance in this area, especially on this back side.
Several song-filled hours later.
And by this point, it was finally time to do some test cuts. I'll let you in early on a little secret that I later found out. Out in the garage, I have another feed for my dust collection system, and there's a blast gate out there. And I was doing some work out there, had that blast gate open, and forgot to close it. So for my entire first test cut, I was only getting half suction or less because I had a blast gate open unnecessarily out in the other side of the garage. So real quickly, what we're going to do is get homed and get our work origin set. Then we'll get zeroed down to the material, and then I'll release this lever to drop my new dust shoe down onto the surface of the material, and then we'll run the job and we'll follow along with the camera and see how the dust collection goes. I started with my router speed set a little too high, and here in just a bit I realized that, and I lower the speed mid-cut. I actually lowered it a little too much, I think, and there's a moment where the cut starts to struggle, and then I raise it back up a bit. Okay, before I try to use the vacuum to get the sawdust out of the trough, I want to show you that there is very, very little sawdust. Let me move the gantry out of the way. Okay, so I've got a tiny little bit of sawdust back over here, and a tiny little bit of sawdust on the middle of the piece. I think what was happening is that some sawdust was escaping out the top, and I made that opening bigger by about 1.5 millimeters, because when this is compressing down on here, this can move just a little bit, and I didn't want that inner opening to bump against that collet nut So I gave the opening a little bit more, and I think that's what's escaping, giving this little bit of sawdust here. But all in all, I have to say, to have cut that many chips with a 1/4-inch bit out of plywood, for that to be all I'm dealing with, I'm real happy with that. This was done with this one that I'm calling 1/4 open, and I'll also try again with the 1/2 open and the full open, and then I may even print one that is back closed all the way over to here. Also, I ran the tabs at full height because I wanted the maximum number of up and down motions so that you could see this thing compressing, going up and down and compressing as needed. So it will take some more usage to kind of verify how well this thing stands up over time, but pretty happy with that first usage. Okay, so I feel sheepish, but in addition to remembering to open this blast gate, I forgot to close one on the other side of the wall. So on that first test that I ran, my suction from my dust collection system was only half what it should have been. About half of the suction was being wasted, maybe more than half, on a blast gate that was left open very near to the dust collection machine. So I've since closed that blast gate, and I'm going to run the exact same test again. However, the good news is that even with the dust collection running at only half strength, I still had a really great performance of capturing dust. So now that the dust collection is up to full strength, I'm going to rerun the test on this one. I probably should mention that the stain here is from where these boards got waterlogged. They were resting with this edge down, and they got waterlogged when the flood water came in to my workshop during flash flooding. And so this is yet another instance of me finding ways to use things that would normally be destined for the trash. I designed so that I could cut around the stained area and not have to bother with that. So I'm going to go ahead and cut one more out of this board. All right, so go ahead and do my homing macro. Okay, dust collection on. Hey, future me here. I'm realizing that when the cut comes over on this side where the dust shoe is hanging half off the material, that we're getting decreased suction because the bottom part of the shoe is now against open air instead of against the material. This argues for the shoe being more closed off, not less closed off. So I may not print the half open and full open. I may only print one more test that has the shoe closed off to the degree that the original shoe by Ryan was. And you'll notice, I think, that in the areas where that's not happening, the trough is pretty much clear of chips. And in the areas where that is happening, the trough has lots of chips in it. I could be mistaken, but that's kind of my working theory right now. It doesn't escape my notice that a modification of Ryan's original dust shoe to simply have this trough in the bottom that can hold the EVA foam bristles, and then simply making those bristles longer could be a way to achieve a very usable dust shoe that doesn't involve this linear rod and all of this up and down motion. And if that turns out to be the case, I won't be troubled by having gone to these lengths of experimentation. But I do have to say that this is working pretty good as far as I can tell. Okay, so for much of the cut, the slot is clean, and for other parts of the cut, the slot has some sawdust in it. However, when I back off and look at the big picture, I have practically zero chips or sawdust thrown out either on the surface or around it. I think these little bits were here from the last test. It will take, much more cutting with this to see how this thing does in the long term, but I'll let you look at these results and judge in yourself what you think about them. As for myself, I am having to report that as a success and pretty pleased with how it turned out. All right, this has been Doug with Design 8 Studio with part 3 of the Floating Z Dust Shoe for the LowRider version 3. If you enjoy our content, please click like and consider subscribing. And until the next video, I wish you happy making.